So we're still in 4.2, part 2, and we're going to talk about more. All right, so just a recap, big picture recap, and please, electronics need to go away. So our unit circle, circle radius 1, our center is at the origin. What we did, our whole point of doing the unit circle is, one, it lets us find sines and cosines of angles for special angles really easily. But with that idea of wrapping the number line around the unit circle, we can assign any number to a position on the unit circle, and that lets us find the sines and cosines of numbers, any number, rather than just thinking about angles and triangles. Then what we did to find our sines and cosines of our special angles is we put 30, 60, 90 triangles on the unit circle, or 45, 45, 90 triangles on the unit circle. And that lets us find the sines and cosines of these particular angles. So one of the big ideas from our unit circle is the cosine of theta, whatever, if we're talking about an angle, a number, is the x coordinate. So on the unit circle, the x coordinate always gives us the cosine of the angle or the number. And the sine of the angle or the number is the y coordinate. And knowing the x and the y coordinate, we can find all of our trig functions of all the different trig functions by using those two, because we know the rest of them based on the sine and the cosine, based on the x and the y. The special right triangles let us find the sines and cosines of certain angles. What we'll see is that, I'm going to write it this way, something pi over 6, something pi over 3, and something pi over 4 are always going to be unit circle angles or coterminal with unit circle angles. So when you see these denominators, something pi over 6, something pi over 4, something pi over 3, that should be a clue. We're looking for something on the unit circle. We can find exact answers. We can find the 1/2, the square root of 3 over 2, etc., for these angles. So these are always going to be on the unit circle or coterminal with the unit circle angle. So these denominators are clues that we're talking about in the unit circle. And we'll eventually talk about how we combine angles so we can find the exact values of other things. So we have our x coordinate, we have our y coordinate. We can find the sine and cosine of any particular number, and the coordinates are associated with the sine and the cosine. So that's really our big picture here. What we want to do today is add a couple of ideas to the unit circle. So questions here. All right. So first thing we want to talk about is periodic functions. So what do we mean? What do we mean when we say a function is periodic? Any idea? An everyday word that we could use to mean periodic?
Sometimes.
What's that?
Sometimes.
Sometimes? What happens sometimes? So sometimes. So give me an example of. So I'll go in with that. Give me an example of something that's periodic.
Waking up.
Waking up. How often do you wake up?
By waking up. I don't know.
Once a day.
Oh, how
right? In the morning, you wake up in the morning. So you were thinking, you were asking me what time? You thought I was asking what time?
How do you wake up?
No. So someone else said every morning, every day, right? Once a day, we wake up at least once a day. So what happens? What does that tell us? It's happening with waking up. It's doing what? Consistent, and it repeats, right? Go to sleep, we wake up. Periodic means it repeats. And we want to be a little more precise. We're going to say functions that repeat regularly. So periodic functions are functions that repeat regularly. How often do sine and cosine repeat? Say we're on a point on the circle. What takes us back around to the same point? How many radians? 2 pi. Sine and cosine repeat every 2 pi radians. We get back to the same point. So sine and cosine functions are periodic, and we say their period is 2 pi. Pi radians. Because they repeat when we go around the circle, we get back to the same point. So they're repeating every 2 pi units. And what that means is that the sine of, I'm going to say x plus 2 pi equals the sine of x. I get back to the same place. The y coordinate is the same. The cosine of x plus 2 pi equals the cosine of x. The x coordinate is the same after I go around the circle one time. And I could say plus or minus because we go around either direction. And it also doesn't matter how many times we go around the circle. We go around the circle 100 times and end up back at the same place. So the way we write that is, just to be a little more precise here, is we say that the sine of x plus 2n pi equals sine of x, and the cosine of x plus 2n pi equals the cosine of x, where n equals some integer. And what is an integer?
Number.
What kind of number?
Real number.
Real number. Yes, integers are real.
Whole number.
Whole number. And whole numbers are positive. Integers can be negative. So positive or negative whole numbers. So we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, negative 2, negative 3, etc., etc. And 0 works as well. Because if I have sine of x plus 0 pi, I just haven't moved at all. So that's what we mean by periodic. This can help us solve some kinds of problems now that we know a little bit about the unit circle. So let's look at a couple of the kinds of problems that you might see that involve using the fact that sine and cosine are periodic. Are we good with this so far? This shouldn't be a big revelation. It really helps us out in a lot of ways. So let's say the question that you'll see in your homework, it will say use the period of the function to evaluate. Let's start off with an easy one. Cosine of cosine of 7 pi. So what this is asking us to do is turn 7 pi, break that into 2 pieces, where one of those pieces is a multiple of 2 pi. If we're adding a multiple, so we're doing something blank pi plus or minus, and we're going to have another blank pi. Where one of these is a multiple of 2 pi. What's the closest multiple of 2 pi to 7 pi? 6 pi? How many 6 pi is 2 pi times 3? So 6 pi, and then what do we have to add to get to 7 pi? Plus 1 pi. Well, because cosine is periodic, 6 pi is just taking us around the circle 3 times. So we can ignore that. I'm just going to put the 1 pi there. So that's just equal to the cosine of pi, which is what? Here we are on our unit circle. We're at 180 degrees. The x-coordinate cosine is -1. And if you had something like 178 pi, it would be a lot easier to break that in 178, figure out what multiple of 2 pi goes in there, rather than trying to count around 178 pi's around your circle. So that's a pretty easy example. Let's look at one that involves, it takes a little more work. So sine of 19 pi over 6. We're using the period of the function to help us with this. Now, every year there'll be students who, I can see them with their unit circle and they're trying to count by pi over 6, count 19 of them. You can do it that way, but if it's even bigger, if it was 73 pi over 6, that would be hard. This is going to be a unit circle angle. We said anything with a denominator of 6 is going to be unit circle angle or coterminal with that. So let's break this into two fractions. It's going to be sine of something pi over 6, and we can do a plus or minus something pi over 6, and we want one of these to be a multiple of 2 pi. What's the closest multiple? What's a multiple of 2 pi that's closest to 19 pi over 6? 18 pi over 6. How many pi's is 18 pi over 6? 3 pi. Is that a multiple of 2 pi? No. So we want a multiple of 2 pi. 18 pi over 6 is a multiple of pi. We want a multiple of 2 pi. So then we need to back up a little bit. So what did you say? 12 pi over 6. 12 pi over 6 plus 7 pi over 6. Sine is periodic. Sine, the sine function. This is a multiple of 2 pi. So this is just equal to the sine of 7 pi over 6. And for now we can look on our unit circle. Eventually we'll just know this. Here's my unit circle. And this is a really nice trick. Draw your little picture here. Here's 6 pi over 6. So I'm going to go down here to 7 pi over 6. And I like to exaggerate this small triangle. The sine is the y-coordinate. It's the short side of that 30, 60, 90 triangle. So what's the sine of 7 pi over 6? -1/2. And this little visual piece of the unit circle, that's an extremely powerful tool. Part of what makes the unit circle so powerful is it gives you a visual of what you're talking about. We're at 7 pi over 6. Well, pi is 6 pi over 6. That puts us down here. This is a 30, 60, 90 triangle. So we can visualize that little triangle there and figure out that our sine is -1/2. I draw these little pictures, or I think about them in my head. This is what I see in my head when I think of sine of 7 pi over 6, is this little picture. And when you draw it on a quiz or a test, it can really help. I like when I see the little circles drawn on quizzes and tests. The visual part of it is really one of its strengths. All right, let's look at all right, we'll do a couple more of these. We'll do a couple more of these in just a little bit, using even and odd functions. So questions on using the period of the function to help us evaluate these problems. So we'll look at a couple more like this with another little twist at it. We just have one last thing that we need to talk about. All right. Last thing is even and odd. So this is related to the question 3 from our homework last night. What did we decide an even function was? F of minus x equals what? For an even function. That would be odd. So an even function, f of minus x equals f of x. What kind of symmetry do even functions have? Y-axis. So even means f of minus x equals f of x, and odd, we just decided f of minus x equals minus f of x. And what kind of symmetry do odd functions have? What is it? What's the point? Yeah, you could just say 0, 0. 0, 0 symmetry, that's fine. So origin symmetry. Well, our sine function and our cosine function, one is even and one is odd, so that makes finding these things out, finding things nice. Cosine and the secant are even. So this is true about cosine and secant. So what that means is the cosine of negative theta equals the cosine of theta, and the secant of negative theta equals the secant of theta. Visually, what this means on our unit circle, once we draw a picture, it's going to be it's like, oh, of course that's the case. Here is theta. Draw that a little better. There's theta. There's my x coordinate right along here. Cosine is the x coordinate. Here's negative theta. They have the same x coordinate. This piece of the triangle is exactly the same. Cosine of negative theta equals a cosine of theta. That x coordinate is exactly the same. The rest of the trig functions are odd. So I'm going to say all the rest are odd. So what that means, if we write it out in formulas, that means the sine of negative theta is a negative sine of theta. The cosecant of negative theta is a negative cosecant theta. Tangent negative theta equals negative tangent theta. And cotangent negative theta is negative cotangent. And our picture is exactly the same, but for the odd functions, we're looking at the y coordinate. So we're looking at this piece. The sine of theta is that little y coordinate, that side of the triangle. The sine of negative theta is that same length, but it's down in the fourth quadrant. So the sign is negative, it changes sign. That's what this is telling us. So the x coordinate stays the same, the y coordinate changes signs. That's what this is telling us, the even and odd part is telling us. So we good with that? So let's look at how we're going to use this even and odd function stuff with some problems. Kind of like the last ones that we did. We'll kind of combine the two together. All right. So we want to find. We're using the period of the function. We're finding the exact value of this function. Let's find the cosine of negative 13 pi over 6. Well, rather than having to deal with a negative angle, let's deal with that negative sign first. The cosine function is even or odd? Even. So that tells me that the cosine of negative theta is the cosine of, same as the cosine of theta. I don't have to worry about that negative sign. The x coordinates of these two angles are the same. The position on the unit circle. And then we want to break this into two pieces. Some fraction pi over 6 and another fraction of pi over 6. So that one of these is a multiple of 2 pi. This one's pretty easy. So what's the closest multiple of 2 pi? 12 pi over 6 plus pi over 6 gives me 13 pi over 6. 2 pi takes me around the circle another time, so I can just ignore that. And then we're looking at for the cosine of pi over 6. So here's my unit circle. Here's pi over 6. This is the short side of the long side of this 30, 60, 90 triangle. So that's going to be square root of 3 over 2. We're talking about this piece, the long side of that 30, 60, 90 triangle. So we used the fact that cosine was even to deal with that negative sign, and then we use the period to figure out that the cosine of 13 pi over 6 is the same as pi over 6. All right, one more. Sine of negative 9 pi over 4. That 4 in the denominator says this is going to be a unit circle angle or coterminal with a unit circle angle. But let's deal with that negative sign first. So the sine function, even or odd? Odd. So what does that do with this sign? Makes the sign negative. You can kind of think that we're bringing it out front. Sine of 9 pi over 4. And then we're going to, that's going to be a negative. Break this into two fractions where one is a multiple of 2 pi. So what are my two fractions going to be here? 8 pi over 4 plus pi over 4. That one's pretty easy. So I get negative sine. This takes me around the circle. So I just get negative sine of pi over 4. And the sine of pi over 4 is square root of 2 over 2. So I get negative square root of 2 over 2. So I use the fact here that sine was odd. Use the period to help to eliminate a multiple of 2 pi, and I get my answer. All right, we good with this? Okay. One other thing about using your calculator. Some of the problems on the homework say find these things in your calculator. Remember, if it says t equals 1.74 and there's no degree there, you need to be in radians. So your calculator needs to be in radian mode. You'll get problems that say find the cosecant of 1.74. Your calculator doesn't have a cosecant button. So to calculate this, you need to do 1 over the sine of 1.74. You need to find the sine of 1.74 and do the reciprocal. and it is not the same as this. You're not going to use that letter. That's the inverse sign, which is different than the cosecant. All right? Okay. Homework.